Hey everyone, welcome back to the channel. Today we are diving into a fundamental architecture pattern that many of you may have heard of, but might not fully understand how to apply. The publisher-subscriber model, or more commonly known as the pubsub model. In this video, we will walk through the architecture using AWS services and how it fits perfectly into a real-world scenario, a photo studio application. So let's get started. The pubsub model is a messaging pattern where the publisher emits messages or events to a central hub, and subscribers, whether they are services or application, to act upon receiving those messages. This model allows multiple actions to be triggered by the same event, without the publisher needing to know what the subscribers are doing. Let's bring this abstract concept into something tangible. Imagine you are building a photo studio application where users upload their photos to be processed with different filters. The system needs to notify the users, apply the filters to the images, and create a thumbnail for previews. Using a pubsub model, we can streamline this entire workflow with AWS services. Let me walk you through the architecture. The first component is the user-facing part of the application. Users upload their photos through a web or mobile app. The upload is processed via an API gateway, and the image is stored in an Amazon S3 bucket. Once the image lands in S3, it triggers a notification. This is where Amazon Simple Notification Service (SNS) comes into play. Here's the magic of the pubsub model. Amazon SNS, which is our publisher here, sends a message to all the subscribers whenever a new image is uploaded. In this system, we have 3 subscribers: an email notification system, an image processing queue, and a thumbnail generator. First, the system sends an email to the users letting them know that their photo has been successfully uploaded and is being processed. This is a great way to improve user experience with quick feedback. The second subscriber is an Amazon SQS queue, which handles the image processing tasks. Messages in this queue are processed by an AWS Lambda function. This function applies filters to enhance the image, whether it's making it black and white, increasing brightness, or adding contrast, depending on what the user selected. This third subscriber is a direct AWS Lambda function that generates a thumbnail version of the image. This is perfect for users, galleries, or small previews. Now that you have understand how each piece fits together, let's talk about the benefits of this architecture. First, we have scalability. The pubsub model allows the system to scale by handling multiple independent tasks in parallel without performance degradation. Second, we achieve loose coupling. Each component in this architecture is independent. If the email service goes down, image processing still happens. If the Lambda encounters an issue, the email still gets sent. This makes the system more robust and easier to maintain. And third, the entire process is near real time. Whether the system is notifying the user or applying image filters, it happens almost instantly. So there you have it, a clean, scalable, and efficient system built on AWS using the pubsub model. If you are building systems that need to handle multiple tasks triggered by the same event, This pattern is incredibly powerful. It's also versatile enough to be used in everything from image processing to log aggregation and even IoT applications. Okay, so if you enjoyed this breakdown and want to see more architecture deep dives, be sure to subscribe to the channel, hit that notification bell, and thanks for watching. And I'll see you in the next video.